And that's okay. If we need a little review of everything, that's all right. Just let me know, okay? So let's go ahead and look at that page. And let's look at the bottom part, okay? And so let's just do a quick review on what we're doing here. So pick one of those elements that's on this actual thing. Pick one of those elements. Carbon 12. Very good. Now, little reminder, is that a negative 12 or a dash 12? Dash. It's a dash. Very good, okay? Because that's its mass. Now, don't forget that if it does not match what's on the periodic table, that means it's a what? It's an isotope. Very good. Okay, so your whole objective here is to not only identify your protons, your neutrons, and the electrons, but also to identify whether is this element an isotope or am I going to have a charge, right? What is an ion?
Negatively or positively charged atom.
Yep, any charged atom. Very good. Okay, so let's do carbon 12. What's my symbol for carbon?
C.
C, very good. My atomic number, they're giving it to me, and so that's 6. What's my atomic mass, like specifically? What is all the numbers? 12.01, right? 12.011. Okay, now what's my mass number? Go ahead and round that off. 12, very good. So I have 12 here. How many protons do I have? Protons, do they ever change? No. It never changes, right? It identifies your element. All right? So, and it's always the same as what? The atomic number. Yep, your protons. So my protons are going to be 6 because my atomic number is 6, right? Okay, now how can I find my neutrons? Yep, you're going to take the mass and subtract. And my mass is 12 minus 6 gives me what? 6. Now, is your neutrons always going to be the same as your protons? No. Okay, this is just a little coincidence because it's 12. You always subtract. Yep, the mass minus your protons is going to always give you the neutrons. Okay? Now, if your neutrons change, that's why it gives you a different mass. Okay? All right, so now my electrons, do I have a charge there? Nope, I don't have a charge. So if I have a neutral atom, the electrons are going to be the same as what? As the protons. Very good. You guys got it. Very nice. Okay. Do we want to do something with a charge?
Yes.
Okay. So let's pretend, don't write this on your page because it doesn't have a charge, okay? But let's pretend this carbon 12 was a plus 4. Okay? How would that change my electrons? Yep, because you're gonna do opposite the charge. So here's your protons plus a minus 4. So what would be my electrons? And so that would be my new electrons. Okay? And that's just a little review on what we did with the ions. Okay, your charged elements. Yes? Does anyone have any questions so far? No? Nothing else about this that we need to review?
Protons minus the or plus the 4, right, would be -4.
Right, it's going to give you whatever you have to do to it. It's opposite the charge.
We use protons.
To find your electrons? Yes. Oh, to find the neutrons, it's going to be the mass minus the protons. That'll give you the neutrons. Okay. Yes. Any other questions on this? What are your 3 subatomic particles? Protons, neutrons, and electrons. What's my charge for protons in the atom? Positive. What's my charge for electrons? Negative. And what's my charge for neutrons? There is no charge. It's neutral. Very good. Okay, nice. Okay, now do we need to go over isotopes? Yes?
Yes.
Okay, that was the one of the most asked questions yesterday. Now guys, remember an isotope is when your neutrons change, your mass changes. So here you have the same element with different masses. So what's my first step? What do I have to do to that percent? Yep, you're going to move the decimal twice. So that's going to be a 0.50, right? Or 0.5054. And you're going to multiply it, very good, 0.5054 times your mass, 78.92. How much does that give you? Use your calculator.
39.
Don't guess. Give me an exact number. 0.5054 times 78.92. How much is that? 39 point what? 46. Okay. Very good. Okay, so now what's my next step?
Sheets.
Well, we're not finished yet because we still have another percent over here, right? What do we have to do to that one?
Move this one.
Yep, you're going to move the decimal twice. So 1, 2. So we're going to have 0.4946 times the mass. 80.92. Correct?
Yep.
Okay, so now multiply 0.4946 times 80.9. How much does that give you?
I got 40.02.
40 point what? Okay, 40.02. Okay, now that I've gotten all of my samples, you're going to add them up. Very good. So you're going to add both of them up. 39.46 plus 40.02. How much does that give you? 79.48. Very good. And this is your AMU. What does AMU stand for again?
Atomic mass unit.
Average atomic mass unit. Okay, your average mass unit is really what it is. All right, and that's it. Don't forget to put the unit. Do not forget to show the work. Okay. What question do we have on these? Huh? None? Are we sure? Okay, you're going to do both sides of the review that's due today, okay? If we still have the work from yesterday,